So the point of a scatter plot is to try and work out whether there's a correlation between our two different measurements. And there are two different types of correlation that we could have. So we could have a positive correlation. So that means that as x increases, y also increases. So there, when we look at our graph, our line of best fit has a positive slope. So that's a good thing. The line of best fit allows us to calculate things like the slope of the line, and we can see what's going on. Whereas a negative correlation, as x increases, y decreases, and then the line of best fit has a negative slope. And it's not always so simple that the line of best fit is just a straight line like that, but these are some good general guidelines. There's also something called the correlation coefficient, which you won't be asked to calculate, but I'd like you to know what it is. Correlation coefficient. And that quantifies the strength of the correlation. And it's a number between -1 and +1. So if we have a straight line, so here we've got a perfect correlation, so everything's perfectly on a straight line, so this would have +1. That's the perfect correlation. So everything is in a perfect straight line, and it's plus because it's a positive correlation. Okay, but then if we had something, for example, something a bit like this. So here we've got, you can see that there's a correlation, so we could put a line of best fit through like that. But it's not perfect. It's a negative correlation, so this is roughly minus 0.5. So here this minus is because it's got a negative correlation. So here they're correlated but spread out. And that could be due to a variety of reasons why that variation exists around the line of best fit. And then sometimes there's simply no correlation between your two measurements. And in that case, the correlation coefficient would be equal to 0. Okay, so -1 is a perfect line with a negative slope, 0 is no correlation, +1 is a perfect line with a positive slope.